So we're going to continue on with our handout and move on to exercise 3, where we look at a different equation, y squared equals x cubed plus x squared, and we're going to try to discover the graph. This is another tricky one, another really complicated situation, but it's just sort of fun to see how much we can figure out before we use technology to help us. So we're going to start out the same way as the previous exercises where we look for intercepts, right? Find out x-intercepts, set y equal to 0. And I'm taking the equation y squared equals x cubed plus x squared now. So if I set y equal to 0, 0 squared equals x cubed plus x squared, or 0 equals x cubed plus x squared. Now I have to solve this equation for x. And to do that, I have to do something called factoring, right? I can remove common factors on the right-hand side. There's a common factor of x squared times x plus 1 in parentheses. And that's great because that allows me to split this up into two separate equations, either x squared equals 0 or x plus 1 equals 0. The only way x squared can be equal to 0 is if x is equal to 0. I mean, you could take square root of 0, it's just 0. 0 is the only number that has only one square root, by the way, right? Or x plus 1 equals 0, so x is equal to negative 1. So I actually get two x values here. So I have x equals 0, y equals 0. And my other one is x equals negative 1, y equals 0. So those are my two x-intercepts. Let's find y-intercepts if I set x equal to 0 in this equation. Recopy. Y squared equals 0 cubed plus 0 squared. Well, everything on the right-hand side is 0. I have y squared equals 0. That can only happen if y is 0. I mean, if you want, you could write y equals plus or minus the square root of 0. But there's no such thing as plus or minus 0. There's only a positive or minus 0 is just 0. You don't have to write all that down. There's just one solution, y equals 0. And so it's a point we already found up above. In fact, 0, 0 is both an x-intercept and a y-intercept. The origin is the only point that's an intercept, would be an intercept for both axes. So part B didn't really give us anything new. It gave us a point we already had. So we're going to keep going through these different parts. And again, if we were graphing on our own, we could just pick x values, y values. We might just pick at random. I'm guiding us along a little bit here, and by suggesting values for x and y. In this case, x equals 1. So let's see. If I set x equals to 1, I get y squared equals 1 cubed plus 1 squared. But 1 cubed is 1. 1 squared is 1. So I have y squared equals 1 plus 1, or 2. So now I actually do have some square roots here that I can take, right? Y is going to be plus or minus the square root of 2. And I have two solutions for when x is 1. One positive square root of 2 and one negative square root of 2. Square root of 2, again, for point plotting purposes, I would go to my calculator and get a decimal. It's about 1.41. So let's keep going through the next couple parts of this exercise. Let's get all these points together before we start plotting and graphing. So we want to find all points for which x is equal to 2, right? So we have y squared equals x cubed plus x squared. When x is equal to 2, we get 2 cubed plus 2 squared. So y squared is equal to 8 plus 4. 2 to the third is 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. Y squared is 12. So y is equal to plus or minus the square root of 12. And now I hope you've had some practice simplifying radicals. If you're really stuck, you can just leave it square root of 12. It's not that big of a deal, but we can factor 12 into a perfect square 4 times 3. So y equals plus or minus 2 square root of 3, right? 2 radical 3. That's 2 times radical 3. And so we have 2, the x-coordinate, 2 radical 3, positive 2 radical 3, and x equals 2, y equals negative 2 square root of 3. And here also I got a decimal for on my calculator for 2 square root of 3. You can either plug in that or square root of 12 directly. It's about 3.46. So we're going to need that for point plotting in a couple minutes. And now part E, find and plot all points on the graph for which x equals negative 1/2. And why a fraction, you may see why in a little bit when we start plotting. I realize this is going to be kind of a mess, right? Y squared equals negative 1/2 cubed plus negative 1/2 squared. We get so used to working with integer values, we kind of forget about fraction skills, but the fractional values here are going to be important, you'll see in a little bit. Now, negative 1/2 cubed is negative 1/8, negative times negative times negative, but negative 1/2 squared is going to be positive 1/4. And I guess I would add those two together before I would try to take square roots. So a common denominator on the right is going to be 8 to add them. So, oops, sorry, that's negative 1/8 plus 2/8. So y squared is equal to negative 1/8 plus 2/8 is 1/8. So y will be plus or minus the square root of 1/8. And let's clean that up a little bit. Y equals plus or minus the square root of 1 over 4 times 2. So y is plus or minus the square root of 1 is 1. Square root of 4 is 2, radical 2. And if you rationalize, this is going to be 1 over 2 radical 2 times the square root of 2 over itself. So y is plus or minus square root of 2 over 2 times 2, or y is equal to plus or minus square root of 2 over 4. So quite a bit of simplification going on there. If that just is like just driving you nuts, just stop earlier on. If you work with the square root of 1/8, that's basically okay. That's not that big of a problem. But here is the simplified form in the square roots. So let's see, x was negative 1/2, y is square root of 2 over 4, and we got x equals negative 1/2, negative square root of 2 over 4. And for that square root, I have a decimal on my calculator too. It's about 0.35, so we'll need that to help us plot points. And the point plotting we're going to do in the next segment.